Hello everyone and welcome once again to my channel. This time we are going to be having some series of questions in chemistry for those that are yet to write their Jamb exam. For those that have already written, at least from my previous videos, there were testimonies of how they saw questions in the hall. Now these questions are actually questions that came out word for word, so don't joke with them. Now I'm going to reveal the answers to these questions and also explaining areas that you need to cover. I know that we are barely having just little time for those that will be writing, I think on Monday and Tuesday, then on Wednesday. We are going to be having little time. But then, if you are able to go through this video and also check my previous videos, then you should be set. One thing about attempting JAM questions correctly is that you have to be smart. You must be smart in the way you select your answers and the way you think through. All right. So on the board, we are having 9 questions. So let's quickly dive into looking at them now. Looking at question 1. Question 1 is the IUPAC name of this structure. This is under organic chemistry. So which is CH3, CH, then double bonds, CH, CH2, and CH3. This question is a very, very cheap one. Even the answer is already revealed here, pent 2 in. But how can we get the answer? It's very easy. First thing to do is, we are having how many carbons in this compound? We are having 1, 2, 3, 4, 5. That's 5 carbons in this compound. Then the next thing is, since we are having 5, you should name it as what? As pent. The next thing to do is to number the carbons in both directions. That is forward and backward. 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. Now, which direction are you to go with? We are to go with the direction with the smaller values. And in this case, going by forward is 2 and 3. Between 2 and 3, that's where you have your double bonds. Then for backward is between 3 and 4. So it's better to go with the 2 and 3. Then we are not to go with both numbers. We are to go with the smaller one. So between 2 and 3, the smaller value there is 2. So the name is pent 2. Then since it is a double bonded molecule, then it should be what? In. Remember, single bond is in. Double bonds in. Then triple bonds ine. So that's the name of the compound. Pent 2 in. Alright. Then question 2. The value of N in CnH14 if the compound is a member of the alkanes is, first thing to do is, what's the general formula of alkanes? General formula of alkanes is given as CnH2n plus 2. Now, we are told to get the N value, which is the number of carbons, when our H value is known. So it's obvious that this N here, any value you are writing here, you should multiply by 2 and then add 2 to give you 14. So it's very easy. All you simply do is just bring out this one. It becomes 2n, then plus 2 is equal to what? 14. Why did I equate to 14? Because we already know the value here, which is 14. So we are just saying that anything here should be here. So you have to equate it to 14. So normal mathematics, 2n plus 2 equal to 14. That should be 2n equal to 14 minus 2. You get the point now? So it becomes what now? 2n equal to, why I said 14 minus 2? Because I collected like terms here. So when you collect like terms, you move this plus 2 to the other side, it becomes minus 2. That becomes 14 minus 2 is what? Is 12. Then we divide both sides by 2. At the end, we are going to obtain what? Our end value to be 6. So our end value here is 6. So that's the answer. It's very easy. Or you simply just work with this principle. Then you get your answer. Then question 3. The corresponding alkyl of pentane is, now they are referring to the alkyl groups. The alkyl groups. Now, we have different forms of alkyls. But meanwhile, remember that the alkanes, they form the alkyls when alkanes lose one atom of hydrogen. So it's very easy for you to know that the corresponding member of the alkyl of pentane would be what? Would be pentyl. Why? Because if you have methane as the first member of the alkanes, now when it loses hydrogen, it forms what? Methyl. So what you simply just do is, for you to get an alkyl from alkane, you simply just remove the ane and replace with what? Yl. So in this case, the corresponding alkyl of pentane should be what? Remove ane and replace with what? Yl. So the answer should be what? Pentyl. Is that easy? Assuming they had asked that the corresponding alkyl of butane is, then you just remove the ane and replace with yl. It gives butyl. So it's very easy. Then question 4. The key depletion of ozone layer, The key depletion of ozone layer is caused by, it's very easy. The key depletion, meaning the chemicals that are boreholes in the ozone layer, they are the CFCs, talking about the chlorofluorocarbons, the CFCs. So that's the answer to that question. Then question 5. The formula of the fifth member of the alkynes is, this question is a bit tricky. Remember that for the alkynes, the first member is what? Ethyne. The second member is what? Propyne. The third member is butyne. Then the fourth member is pentyne. Then the fifth member is hexyne. So the fifth member of the alkynes is what? Hexyne. And remember that the general formula of the alkynes is what? CnH2n minus 2. So how do we obtain the formula of this guy? Hex represents how many carbons? 6 carbons. So hence, our end value, which is in this case should be 6. Number of carbons, hex is 6. So our end should be 6. So let's get the formula. That gives us what? C6 H2 times 6, then minus 2. That should give us C6 H2 times 6 is what? Is 12. Then 12 minus 2 is what? 10. So this should be the answer to that question. It is C6H10. So that's the answer to that question. Then question 6. Question 6. We are given the IUPAC name of that same compound now. Okay, CH2, then doubly bonded CCl, then CH and B arrow. This structure can be represented as something like this. Then we are having something like this. It can be represented in this pattern. So why I'm representing it like this is just for you to understand easily on how you can get the name. I think here is 2. So CH2, then Br. So in this case, if you are told to name this compound, it's very easy. All you simply do is this carbon is our longest chain. And how many carbons are there? 3. So are we to go forward or backward? It depends on the direction that will give the least number to that double bonds. That's talking about the carbon to carbon double bonds. So in this case, if you number forward and you number backward, forget about these substituents, just focus on the double bonds. So in this case, going by the forward, our 2 carbons linked by the double bonds are carbon 1 and carbon 2. Then backward is what? Is 2 and 3. So it's obvious we are going with forward, the smaller values. Then now next, between 1 and 2, which one is smaller? Is 1. So it becomes what? How many carbons are there? 3. We have prop. Prop is for 3 carbons. Then prop what? Prop 1. Because between this and this one we should go with 1 what? In. Then next, since we went with the forward direction, we have to go with it all the way. So we are having chlorine and we are having bromine. Now, bromine is seated on carbon 3, while chlorine is seated on carbon 2. So it's best to arrange it alphabetically, in that the B should come first before C. So that becomes what? 3 bromo, then 2 chloro, prop 1 in. So that's the name of this structure. 3 bromo, then 2 chloro, then prop 1 in. So that's the name. All right. So the next question, question 6 or question 7 rather. Now looking at this, we are given CH3 CHO and we are given CH3 CO CH3, and then we are asked for the name of these two. Now, not just the name, they were actually interested in the family. According to how I got the question, they were interested in the family. Where can you find these two? Of course, this is a member of the alkanals, then while this one is a member of the alkanones. As a matter of fact, pay attention to this. Alkanals, they are known by the general formula ROCHO, while alkanones, they are known by the general formula ROCOR. So these ones are alkanals, also called aldehydes. Then while these ones, they are alkanones, also called ketones. Between this and this, the ones that can give a reaction with Ferlin solution as well as Benedict solution forming brick red coloration are the alkanals. So take note of that. They might also ask you a question on it. So just know it's the alkanals. So these two, they are alkanals, alkanal and alkanone. Alkanone. So take note of that. Even when you come across, there was actually a question I stumbled on, and the question was written in this form: CH3, CO2, then CH2, CH3. Now, this is a member of what family? It is a member of the alkanoids. If you have watched my video lesson on alkanoids, you are not supposed to fill this question. Alkanoids are also called what? Esters. And if you should check, the way they wrote the structure is kind of confusing, but you shouldn't be confused. The reason is because if you expand this, it should be CH3, then this guy should be COO, which is this, that O2 is OO, then CH2 and CH3. So this guy is actually the esters, because the esters are known by the general formula RCOO. You get the point now? So this guy resembles this. So please take note of that. Then the next question. Now, this question 8, please take note. They might come in different pattern. They might come even in the representation of calcium or other elements. So how would you go about it? It's very easy. This kind of question, when you see it, I don't expect the student to use up to 5 seconds to attempting this question, because look at it. They gave the orbital representation of a particular element, and then they were like, what's the element? Now, the orbital representation is 1s2, 2s2, 2p6, 3s2, and 3p4. Now, all you simply do, for you to get the name of the element, just add up all these numbers, and then after you've added, you have gotten it. Then that number, you recite your first 20 elements. That position, that number that you got, any element there becomes the answer. So in this case, 2 plus 2 is 4, then plus 6, 10, plus 2, 12, plus 4, 16. So 16, what element is found in position 16? Of course, is what? Sulfur. So sulfur is the answer to that question. Sulfur. Then next, hydrogenation is used to convert coal to liquid hydrocarbons. But if you don't see this in the option, you can go with what? Petrol, because petrol is an example of gasoline. That's another name of petrol. It's an example of liquid hydrocarbons. That process is called the Bagios process. Bagios process. So let's look at the next question. The next question, question 10. Now we are given an equation here: KOH H4 NO3, then to give KNO3 H2O and ammonia. Now they said the reaction above is fourth. Of course, the answer to this question is alkali. Why is it alkali? Now, because we are dealing with what? KOH. Now, this is actually one of the chemical reactions of bases. That's, you know that all alkalis are bases, but not all bases are alkalis. And what are the two main classical examples of alkalis? KOH and NaOH. So generally, when bases react with ammonium salt, they liberate ammonia gas, which is NH3. So that reaction is a reaction of an alkali. The next question, question 11. When potassium nitrate is decomposed, dash and oxygen is formed. Now, potassium nitrate is KNO3. When it is decomposed, when heat is applied, it produces KNO2 plus O2. That is potassium nitrite. That is potassium nitrite. All right. So if there are two nitrates that when they decompose, they form their corresponding nitrite as well as the release of oxygen. And what are they? We have sodium and potassium. These two, they form their corresponding nitrites and the release of oxygen gas. Then as for calcium, magnesium, and most of the other metals, when their nitrates decompose, they form their corresponding metallic oxide and nitrogen 4 oxide with the release of oxygen gas. Then, of course, for that of, I think, silver and gold, when their nitrates are decomposed, they are decomposed into their metallic form, and then nitrogen 4 oxide as well as oxygen gas. So that's just what you need to take note of. Then the next question, because the answer to this question now is what? Is KNO2. Then the next question, question 12. Dash is an aromatic hydrocarbon. I think the option that made sense was phenol. Phenol. When we say aromatic, anything aromatic talks about benzene, the presence of benzene. And of course, the ring of benzene is drawn like this. When you see this chain, just know it's for what? It's for benzene. That's benzene ring. So when you have OH on top of benzene, attached to benzene, that's called phenol. So OH is called phenol, and that's an aromatic hydrocarbon. Any compound that is formed as a derivative of benzene is considered aromatic hydrocarbon. So the answer is phenol. That's when you check your options. Then question 13. Cathode of dry Leclanche cell is, the cathode is carbon. Then while that of the anode, in case you see a question, they might twist it. Anode is zinc rod is anode. Then while cathode is carbon. Take note of that. Then question 14. Which of the following gases in the air acts as a diluent? Is, of course, nitrogen. Nitrogen gas is the gas that acts as a diluent. It tends to slow down corrosion as well as combustion. Then now question 15. Steel is made up of iron and carbon. Steel is an example of alloy. So it's made up of two elements. The two elements are what? Iron and carbon. So take note of that. Then next question. Decarboxylation of ethanoic acid yields dash. Decarboxylation of ethanoic acid yields dash. Now ethanoic acid is CH3COOH. Then when you carry out decarboxylation, meaning you are going to remove this in the form of CO2, then when you do that, you have to be left with what? CH4. And what's CH4? CH4 is methane. So the decarboxylation of ethanoic acid yields methane. I don't want to waste much time on this. All right. Then next question. Ammonia, NH3, and dash are used for fountain experiment. First and foremost, what is fountain experiment? It is simply an experiment that is conducted to test for the solubility of gases. And in the world of chemistry, there are two extremely soluble gases: ammonia, NH3, and hydrogen chloride gas, HCl. So the answer to this question is HCl and ammonia. They are both used for fountain experiment. Then the next question. Which of the following exhibit geometric isomerism? So it's based on what you are seeing in the option. Any alkene, because I'm pretty sure that if they are giving you options, only one will be a member of the alkene. So any alkene can exhibit geometric isomerism. Why? For a compound to exhibit geometric isomerism, the first criterion is that the compound needs to possess what? Double bonds. That's carbon to carbon double bonds. And not only that, the two carbons linked by the double bonds should contain same groups, and they can be arranged in different orientations. Now you could be having the cis orientation or the trans orientation. So that's the reason why geometric is also called the cis trans. So any alkene can go in that pattern and then it can function. I think the correct option was butene, which is C for H8, butene. Then next question. The ions responsible for causing hardness of water are, the two main ions are calcium ions and magnesium ions. So calcium ions, magnesium ions, they are responsible for hardness of water, whether permanent or temporary. Then the next question. The fraction of petroleum with a temperature range of 40 to 200 degrees Celsius is gasoline, also called petrol. So take note of that. Take note of all these questions. And again, another very important or vital thing that I would need to clarify is that they might not be bringing the question exactly the same way it's written here, but then have this confidence. Be very confident in what you are doing and make sure you should be very, very smart, because now they might not just bring it exactly the same way. So what are you supposed to do? You use the knowledge you have gathered from here to be able to work to attempting the questions correctly. And again, if you see any calculation questions, they might bring calculations on gases, that's gas laws. So the thing is, if volume and temperature is given, just know that that is Charles law. So when you see volume and temperature given, then you should know that you are using V1 over T1 equal to what? V2 over T2. What about if you see pressure and volume given when there is no temperature? Then you should use P1 V1 equal to what? P2 V2. This is obvious. It's coming from Boyle's law, while this one is coming from Charles law. You get the point now? That's under gas law. So when you just see questions like that, be very smart and know what to do. Then not only that, there was a time I did a video lesson on this channel, and it was on stoichiometry of chemical reactions as well as solubility. I gave shortcut formula for them. Now, if you see any question that you are provided with, let's say you are given the mass of a substance and then you are told to calculate the solubility of the substance and you are given the molar mass and the volume, what are you supposed to do? Just run, work with this formula and then you get your answer with smiles on your face. This formula will be of help. The mass, write it here. So anything you are given in mass now, let's say 16.2 grams, write it here. It becomes 1000 times 16.2 grams over what? The molar mass of the substance that you are given, write it there, then multiply by the volume. You don't get answer. Let me use PG. I've obtained the answer already. So the thing is this, just try your best possible to ensure that you are very smart and then know the right answer to go with, and don't be very, very much in a haste, because this is actually Jamb, and if you are not careful you might end up not getting what you expected. But then be very smart, you will come out with flying colors. And again, never should you be using because it came out in my friend's home then certainly it will come out in mine. It's never true in all cases like that. All right, so just be smart and then go through the video lessons that I've done. Even apart from this, go through the video lessons that I've been doing ever since. It will be of help to you. All right, thanks for watching and I wish you guys all the best in your forthcoming JAMB examination.